we've got a composite area, and we're going to try to look at some more difficult examples of this today. This one's pretty routine. It's already been chopped up for you into polygons you recognize. So we've got two rectangles and a triangle. Let's find the area for each. The 5 by 6 rectangle has an area of 30 square inches. And this rectangle is a little tougher to figure out. We've got a measurement of 15, but that goes all the way across the bottom of the figure. So we're going to have to chop it off right here, and we don't know that length yet. We also don't know this side, but that's a little easier. So if 10 goes all the way to the top and all the way to the bottom, we can actually subtract out 6, and we find that this is 4 inches right here, from here to here. So this is 4 by something, but we don't know what yet. We do have 5 inches here, okay, and we've got 7 inches here. So altogether, that is 12 across here, all right? And that's very handy because 12 taken from 15 leaves 3 for this little bit right here. So we've got a 3 by 4 right triangle right there. If you're wondering about this little hash mark, that is the same mark as this one here, so that means that that's 5 inches. Turns out we don't need it, but an alternate way to find the 3 would have been to use Pythagorean theorem with the 4 and 5 and subtract their squares to get 3. So I think we've got everything we need. The big rectangle is 4 by 12, so that has an area of 48 square inches. And then our right triangle is 3 by 4, so 3 times 4 is 12. Half of 12 is 6, and triangles are always half. So now we just add all these things up. We've got 30, 48, and 6. And that is 84 square inches. Done. Here's one where a half a circle is stuck on the side of a trapezoid. So we need to find the area of both of those. Now that half circle, we can use pi r squared. We just divide it by 2 to get half of a circle. Since the radius is 2, that becomes pi times 2 squared, which is 4, all divided by 2. You can reduce right here. So that's 2 pi right here. That's our area. Now we've got a trapezoid. And with trapezoids, you need to identify right away where are the bases, where is the height. We find the bases where the parallel sides are. So 3 is the top base. And this length right here is the other base, but we don't have any measurements. So let's figure this out. Well, it's 3 for this portion up to here. And then we've got a radius and a radius. So this is like 2 plus 2 more. So altogether, that is 7 for that base. And the formula for area of trapezoids is to average the two bases and multiply by what the height is. The height is the distance between the bases. So this is going to be our height right here. We call this base 1 and this base 2. So let's try it. We add the two bases and divide by 2. That gives us the average base, and then we multiply by the height, which in this case is 4. So I've got 10 over 2 is 5 times 4, which is 20 square feet, both of those. So altogether we've got 20 plus 2 pi square feet. Now, another way to do this problem would have been to divide the trapezoid into a right triangle and a rectangle, and figured out that way with 3 areas, and that will come out exactly the same. Okay, finally, we've got an example with some missing pieces. So we're going to use subtraction. We're going to start with the rectangle that is this large outline, find the area of that, and then subtract out the white spaces to see what the gray area is. So we need to know our 2 dimensions of the rectangle. Looks like we've got 60 plus another 30 here. So 90 altogether on this side, and 60 down this side, the width. So we've got 90 times 60, which is like 9 times 6 with 2 zeros. So 5,400 so far. That's the entire rectangle. So I'm going to put a little rectangle by it so we don't forget. Okay, then we need to do some subtracting, but let's look at this area that's cut out. This isn't a circle, it's a sector of a circle. Since this is 90 degrees right here, 90 out of 360 is 1/4. So we're going to take 1/4 of the circle. So we're going to use our regular circle formula for area, but divide it by 4. Okay, the radius is given as 30, so that's pi times 30 squared over 4. Okay, it's pretty easy to square 30. That's just 900, but don't forget the 2 zeros when you square that, over 4. And 4 goes into anything that 100 goes into, so we do need to reduce. Turns out that it goes into that 225 times. Okay, and there's the area that we need to take away for that little circular segment. Okay, and finally, let's look at the triangle. So our triangle is 60 by 45. We're going to multiply those and divide by 2 because it's a triangle. I can reduce ahead of time, which I like to do whenever one of the dimensions is even. I always divide it by 2 right at the beginning. Then I just have to do 30 times 45, which is 1,350. Okay, now we need to do some subtraction. It looks like we have 5,400 total, but we're taking away 225 pi, and we're taking away 1,350. Now these are like terms and the pi is not, so it's just going to stay on its own. But we can go ahead and subtract those two things. So 5,400 minus 1,350 is 4,050 minus 225 pi. So this is in terms of pi. The units are not designated, so we say square units. And if I was grading this, I wouldn't be able to find that answer, so I'm going to put a nice box or a circle around it to set it off. And that's as simplified as we can leave our answer. That's an exact answer. If you're asked to find that answer to the nearest tenth or hundredth, then you need to plug in decimal approximation for pi and round it to the appropriate number of digits. And that is composite area in a nutshell.